Problem 101, Quantum Mechanics. The question is, consider the potential V of R equal to sum over I V0 A cube del cube R minus Ri, where Ri are the position vectors of the vertices of a cube of length A centered at the origin and V0 is a constant. If V0 A square much less than h bar square by m, the total scattering cross section in the low energy limit is. Here the potential is given. We have to find out the total scattering cross section in the low energy limit. The given potential is sum over I V0 A cube del cube R minus Ri, where Ri are the position vectors of the vertices of the cube. Now what is f of theta phi, the low energy scattering amplitude? It is minus m by 2 pi h bar square integral V of R d cube R. Here V of R is sum over I V0 A cube del cube R minus Ri. Here Ri are the position vectors of the vertices of the cube. Now consider the first vertex. For the first vertex of the cube, the low energy scattering amplitude f of theta phi becomes minus m by 2 pi h bar square integral V0 A cube del cube R minus R1 d cube R. We can write it as f of theta phi is equal to minus mv0 by 2 pi h bar square A cube integral del x minus x1 del y minus y1 del z minus z1 dx dy dz, or f of theta phi is equal to minus mv0 A cube by 2 pi h bar square 1. The integral is 1 because it is Dirac delta function. Now consider all vertices of the cube. We can say that f of theta phi is equal to 8 times minus mv0 A cube by 2 pi h bar square, or f of theta phi is equal to minus 4mv0 A cube divided by pi h bar square. This is the low energy scattering amplitude. Now let us find out the differential scattering cross section. It is nothing but the modulus of the scattering amplitude square. Here it is 16m square V0 square A raised to 6 by pi square h bar raised to 4. This is the differential scattering cross section. In the present problem, we have to calculate the total cross section sigma. This is integral theta is equal to 0 to pi, phi is equal to 0 to 2 pi, then d sigma by d omega, that is 16m square V0 square A raised to 6 by pi square h bar raised to 4, then sin theta d theta d phi. This implies sigma is equal to 16m square V0 square A raised to 6 by pi square h bar raised to 4 into 4 pi, because integral 0 to pi, integral 0 to 2 pi, sin theta d phi is 4 pi. Therefore, our total cross section is, we can write it as sigma is equal to 16a square by pi, then within bracket mv0 A square by mv0 A square by h bar square whole square. Therefore, we can say that from the given option C is the right option.